For this charge tape labs, I created a charged piece of tape by pulling apart the sticky side of one strip from the non-sticky side of another. The purpose of this lab is to determine the amount of excess charge on the tape. This lab is based on these two physics principles. Newton's second law shown here is relevant because it allows us to determine the electric force acting on the tape, seeing as the net force of the system is zero. The diagram on the left shows how the experiment was conducted. Using tape B as the object, we see there are two forces acting on the tape, the gravitational force and the electric force. From Newton's second law, we now know that the electric force is equal to the gravitational force acting on the tape. From there, we will be able to solve for the charge of the tape using the following equations. In the experiment, the tape length was 0.225 meters. I found the mass of the tape using the length and mass per length standard for tape, and the distance from tape A at which tape B began to float was 0.025 meters. With these measurements, I was able to conduct the calculations based on the principles previously mentioned. I found the gravitational force, which is equal to the electric force, and used that to solve for the charge of tape B, which I found to be 1.24 times 10 to the negative 8 coulombs. I found the number of electrons, the surface area of the tape, the number of atoms, and the ratio of electrons to the atoms on the surface of the tape using the equations shown here. Here's my computational model. I started my code by defining my constants like the measurements, and I recorded typical constants like K, atom length, and electron charge. Then I wrote the code for the same calculations I found in the previous slides. Running my code, I found that the magnitude of the charge of the tape to be the same as my earlier calculations, 0.002205 newtons. To approximate this charge, I had to make some assumptions. I ignored air resistance on the tape and I treated each tape as if its charge were located at a single point at its center. In these lines of code, I created the model on the right. The red ball represents tape B and the blue ball is tape A. The blue arrows show the electric force and the green is the gravitational force acting on tape B. In conclusion, what if electrons had a positive charge and protons had a negative charge? The charge of the tapes would be the same, but the signs would be different. Also, the tapes would still repel each other. It is important to handle the charged tapes as little as possible so that the charge of the tape does not dissipate through your hands or any other object that may cause it to lose its charge.